So, welcome to the session, students. We were discussing about rational numbers and the behavior of these rational numbers under different operations and how this behavior of numbers changes under different operations, right from the collection of natural numbers, whole numbers, integers and now to rational numbers. So, in continuation of this, whatever we are going to discuss here today is the further properties of rational numbers, and that is, in the closure we saw that when you combine two numbers, you should again get a number of the same set. In commutativity we saw that when you operate two numbers from a number system or from a collection of numbers, you should get the same value when you interchange them. For example, when you say a plus b and b plus a, both of them should give you the same value, whether it is natural numbers, whole numbers or whatever. I just took plus as an example. There are 4 operations, you should be able to check it for all these operations. Now, next in this particular series is a property in which we will see how the numbers behave when you shift the numbers, when you shift the particular combining thing from one number to the other. For example, if I say 2 plus 3 plus 5, what are you doing here? You are combining these two numbers first. The moment I put it in the bracket means these two numbers have to be combined together, and then whatever you get should be added to 2 is the same as, what do you get here ultimately? This is nothing but 2 plus 8, that is nothing but 10. But what will you get if I shift this particular operation as 2 plus 3 plus 5? What will you get here? Now, you will see that since I have put a bracket here means it is an indication that I have to combine these two numbers first, and then whatever I get should be added to this number. So, it means that this is nothing but 5 plus 5, which is again equal to 10. Let us have a closer look at this. We have combined these two first, and then whatever we got we added it to this. 3 plus 5 is 8, 2 plus 8 is 10. Here first we added these two, we combined these two under the operation of addition, and whatever we got, that is 5, has been added to 5 again to get the number 10. In both the cases you can see that you are getting the same thing, and so I can write this particular thing as 2 plus 3 plus 5 is equal to 2 plus 3 plus 5. It looks quite simple when addition and multiplication are there. Similar thing can happen for multiplication as well. What will happen? Suppose I say 4 multiplied by 3 multiplied by 2. What do I do here? I first combine these under the operation of multiplication, and I get here 4 multiplied by 6, which is 24. I shift this bracket here, that is I combine the other two elements here. So, I get here 4 into 3 multiplied by 2, and so first of all I will combine these two. I will get here 12 multiplied by 2, that is equal to 12 into 2, and that is equal to 24. What do you get here? You are getting the same answer there, they are getting the same number there. So, I can say that 4 multiplied by 3 multiplied by 2 is equal to 4 multiplied by 3 multiplied by 2. These properties are important because they help us to simplify many of the complicated such arithmetic problems there. For example, if you have got a long chain of such addition, subtraction or multiplication, you can quickly search out for numbers that can be combined quickly. For example, if I have the numbers like say 13 plus 14 plus 7 plus 6. I have just taken comparatively a smaller expression here where there are only 4 terms, and you can find that I have the facility to add these numbers at will. One way is I just go on adding this, I get some number there. The other way is, can I think of additions so that I get some numbers that can be quickly added. For example, I can say that this is 13 plus 7 plus 14 plus 6, and in both the cases I am getting 20 plus 20, which is equal to 40. An easier way of doing that. Here what did I do? I shifted this 7 nearer to 13 and this 14 nearer to 6. But how can it be shifted unless and until the rules allow me to do that? And what are the rules that are applied here? I shifted this here by the commutative property, that is 14 plus 7 is nothing but 7 plus 14. Then I use the associative property that I combine these two, and then finally what I get is this 13 plus 7 is easier to calculate than 13 plus 14 or 7 plus 6. 14 plus 6 is comparatively easier for me to calculate, and it is easier for me to calculate the final answer as well. So, you can see how properties help us to do that. Similarly, in the case of multiplication also. Now, here whatever we did here in the case of these numbers, we call this as associative property. We call this particular property as associativity or associative property. In this particular property, what we have done? You have combined the numbers in different way. That is, first I combined B and C under this operation, then I combined A and B, and then combined it with the remaining number. I find that both these expressions, mathematical expressions, are same. So, I say that this is equal to this. Same thing will happen under addition also. Now, will it happen for rational numbers also? Let us check this. Let us take an example. 1 by 2 plus, I am taking the operation of addition here, 1 by 2 plus minus 3 by 2 plus say 7 by 2 is equal to, what I am doing here? I am combining these two rational numbers, and whatever number I get, that I will add to 1 by 2. So, what do you get here? 1 by 2 plus minus 3 plus 7 is nothing but 4 by 2, and that is nothing but 5 by 2. I am getting this rational number finally. What did I do? I combined these two and then added it to this. Now, shift this bracket here, that is, take the other way of combining the numbers, retaining their order same. Retaining their order will combine the numbers in a slightly different way. So, 1 by 2 plus minus 3 by 2 plus 7 by 2 is equal to minus 2 by 2 plus 7 by 2, and so finally what do you get? 5 by 2 again. So, these different combinations of numbers, that combination of numbers in different ways, this facilitates or this generates the property of some of the numbers, rational numbers, that we call associative property, associative property for rational numbers. But remember, as I said, associative property is there. Remember, as I said, you need a collection of numbers and you need an operation, and try to check whether that operation works for that particular collection of numbers or not, means it satisfies the different properties or not. The moment, as we have seen earlier, the moment you change the operation, keep the collection of numbers same, the particular behavior of numbers will change. For example, in the case of whole numbers, for addition it was closed, but for subtraction it was not closed. In the case of integers, for addition they were closed, but for subtraction also they were closed, but they were not closed for division. So, in the case of non-zero rational numbers, I will emphasize on the word non-zero. For non-zero rational number, it holds for division as well. It means, if I talk about all the 4 operations and operate it on the numbers, rational numbers, all these properties will hold. So, it is interesting to see and collect this data and collect this at a particular place to see how the numbers behave as soon as the collection of numbers are extended. So, we have talked about the associative property. Now, let us see the interesting thing here. For which particular operation it is not associative, which particular number system is not associative for which particular operation. We have talked about natural numbers, whole numbers, integers and rational numbers. The operations were addition, subtraction, multiplication and division. For the first one, we have seen that it is associative. This is associative under the operation of addition. This is associative for whole numbers as well, for integers as well and for rational numbers. What about subtraction? Or let us go for subtraction a little later. What about multiplication? It is associative, associative, associative and associative. Now, have a look at the closure property again. All of them are closed. All of them are closed under this operation. they are associative as well. All of them are closed under multiplication, they are associative, they will satisfy the associative property as well. Have a look at this operation now. Will it be associative under subtraction, the natural numbers? For example, if I take 2 minus 3 minus 5 and if I take 2 minus 3 minus 5, I have got these two different expressions. 2 minus 3 minus 5, you can say, or a minus b minus c and a minus b minus c. What do you get in the first case? Here you will get the answer as this is minus 2, 2 minus of minus 2. Now, the first thing is, the moment I say that they are natural numbers, this 3 minus 5 does not have any meaning then, because 3 minus 5 is not going to be a natural number, and so we cannot proceed further. But if I say that they are integers, then only I will be able to proceed further. In the case of natural numbers and whole numbers, this particular thing cannot hold, and it means that associative property will not hold for these two definitely, because they are not closed. They are not closed, so they are not commutative. They are not closed, so they are not associative as well. Let us see, under integers they are closed, whether it will be associative or not. You take the same set of numbers, they are integers as well. So, will you get the same number in both the cases? Here you are going to get minus 2, that is 2 minus 3 minus 5 is nothing but 2 minus of minus 2, which is equal to 4. For this particular thing I am writing 2 minus of 3 minus 5 is nothing but 4. What about 2 minus 3 minus 5? Will you get the same answer here? Try to do it for yourself. So, I get here minus 1, minus 5 and I get here minus 6. So, these two expressions are not same, the values of these two are not same. We will say that 2 minus of 3 minus 5 is not equal to 2 minus 3 minus 5. It means that it is not associative under the operation of subtraction. Similar thing you can try to calculate for rational numbers as well. You will find that this is not associative under the operation of subtraction, this is not associative under the operation of subtraction. What is our observation again? They are definitely closed under subtraction, rational numbers as well as integers. They are, both of them are closed under the operation of subtraction, but they are not associative under these two operations. So, one thing is clear, that if under a certain operation they are closed, it need not mean that they will be associative or commutative for these particular collection of numbers as well. But if they are not closed, then it is definite that they are neither commutative nor associative for that particular operation. So, these particular observations are important. Check for division also. You will find that, so under the operation of division, let us try for natural numbers. What do you get? 4 divided by 6 divided by 3 and 4 divided by 6 divided by 3. Try doing it for yourself. You will find that 6 divided by 3 is 2, 4 divided by 2 is nothing but 2 again. What about this particular thing? This is 4 divided by 6, I will write as 4 by 6, again divided by 3 when you say, this is nothing but 4 by 6 into 1 by 3, and so I get here 4 by 18, or you can reduce it to some simplest form and try to get this number as 2 by 9. Are these two numbers same? These two numbers are not same. So, we can say that it is not associative under the operation of division. Similar thing will happen for whole numbers, integers and rational numbers as well. Let us check it for rational numbers. For rational numbers, but let us mark it here first, that they are not associative under the operation of division. What will happen under the case of rational numbers? Rational numbers is closed under the operation of division, non-zero rational numbers, and I am taking non-zero rational numbers here. 2 by 3 divided by 1 by 2 divided by say minus 2. So, what do you get here? 2 by 3 divided by 1 by 2 into minus 1 by 2, and finally, I will write the final answer as 2 by 3 into minus 1 by 4, or that is nothing but minus 1 by 6. So, this is one way. First of all, these two numbers have been combined, and then whatever result you get, you combine it with this number, the remaining number. Just try to shift the brackets now. 2 by 3 divided by 1 by 2 divided by, what is that, minus 2. What do you get here? 2 by 3 divided by 1 by 2 will mean this is 2 by 3 into 2, and this is divided by minus 2 means this is into minus 1 by 2. The laws of division of rational numbers and the fractions you are aware of. So, what do you get here? 4 by 3 multiplied by minus 1 by 2. So, here you get minus 2 by 3. Yes, because I could have taken that example where it holds, but there are scores of examples, hundreds of examples where it does not hold. Here also this is one of them. In this particular way, mathematical expression, the value is minus 1 by 6, whereas here the value is minus 2 by 3, they are not equal. So, associativity does not hold under the operation of division for rational numbers as well. And every time I am trying to draw your attention to the fact that if a property of closure does not hold, then it definitely means that the other properties like commutativity and associativity will definitely does not hold. But if the property of closure holds, then it may or may not hold for commutativity as well as associativity. Friends, these observations are very important. We expect that you make these observations for yourself and try to operate on different numbers and try to create different examples for others, discuss it with your friends and your teachers, and try to see how these properties are working. So, these were the three properties: closure, commutativity, associativity, and based on these properties we classify numbers also, we see how numbers behave. One more property remains, that is distributive property. Distributive property, how numbers behave when we distribute them. You might have done these problems in your lower classes, but here we are studying it properly as a property. For example, if I have this particular thing, 2 multiplied by 3 plus 4, this is equal to 2 multiplied by 7, which is equal to 14. You can do it with the help of a paper as well, that you can take a rectangular sheet of 3 by 4 dimension and take such two sheets and see what is the area of that, and then you can calculate accordingly. I will do this in another way also. Say I take this as 2 into 3 plus 2 into 4. I take the sheet, as I said, this is a rectangular sheet of dimension 2 and 3 plus 4. This is 3, this is 4. What will be the total area here? You will find that the area of this is nothing but 4 plus 3 is 7, that is 7 into 2, that is 14 square units, that I have already calculated. Try to do this taking a piece of paper, and then you break this, here, cut this particular piece of paper here. You have got now two pieces of paper, piece 1 as well as piece 2. What will be the area of this? The area of this will be 6 square units. What will be the area of this? Because this is 2 again, so this is nothing but 8 square units. If you add both of them, again you are going to get 14 square units. So, the breaking of paper in different ways. Now, it was 3 and 4, it could have been 1 and 4, it could have been 1 and 5, depending on the sheet that you are taking, and you can break it up in different way. Now, this is 3 plus 4, that is 7, this is 7 units, 7 centimeters I can say. I can break this 7 centimeter as 3 plus 4, I can break it up as 2 plus 5, I can break it up as 1 plus 6, this 2 remaining the same. And in each of the cases try to see what kind of areas you are getting, whether they are different or the same. When I say it is 2 into 1 plus 2 into 6, 2 into 1 plus 2 into 6, what is the area? 2 into 1 plus 6, what is the area? 2 into 2 plus 2 into 5, what is the total area you are getting? And 2 into 2 plus 5, the total one. So, whether you are getting the same or not, and you will be very much happy to see, you will be joy to see that these two things, when you are practically doing using a piece of paper, the things are holding there. It is not just the numbers that are important. This particular property has been observed using some concrete examples also, and then this has been taken in the number system. So, this is one of the properties that we call as the distributive property. So, here also I am going to get the answer as 6 plus 8, that is nothing but 14. Using a piece of paper and calculating the area. The numbers here were denoted, or the numbers here were associated with some units, practical units that you take, centimeter, meter, millimeter, whatever, or inches. Nowadays we do not use that unit, just for an example I quoted, and they are not just numbers here, now they are concrete things. So, 2 centimeters, the area, when you get 2 centimeters as the breadth and 3 and 4 centimeters as the length, what do you get? The area, when the breadth is 2 centimeter, length is 3 centimeter, breadth is 2 centimeter, length is 4 centimeter, what do you get? So, the moment you try to do these things at your home, cut out the pieces of different dimensions, cut them in such pieces, divide them in such pieces, and try to see whether you are getting the same result or not, and that is what we call the distributive property. Now, distributive property for rational numbers, when I say distributive property, that is what is happening here. You can see that the operation of multiplication is being distributed. This 2 multiplied by 3 and this is 2 multiplied by 4. This operation is being distributed over which particular operation? Over the operation of addition. So, under the operation, under this particular operation, you will find that distributivity occurs. And so, this particular thing happens for the rational numbers as well. Try to see it for yourself, taking different combinations of rational numbers and see whether distributive property holds or not. So, students, today we have studied, or we have discussed the different properties in this particular session, and I hope you will take some pains to work out on these numbers in different ways, on addition, subtraction, multiplication, division, and so on, and try to verify for yourself whatever has been discussed in our sessions today. So, thank you so much. That is all for the day.